Alright, good day class. You're welcome once again to Master Science Guide. Today we're going to be looking at something very interesting in the world of organic chemistry. Alright, and this is the auto meta or para system. How can you easily identify, know which side is auto, which side is meta, and which side is para? Now, it is very easy. Please take your time to understand the concept. Now, I gave three examples of compounds here. Of course, seeing these are what? Benzene ring, right? These are benzene ring. Okay, so I want to use this to explain something. Now, you see this a benzene ring carrying a functional group COOH. This is a benzene ring carrying a functional group OH, and this is a benzene ring carrying a functional group CHO. The name of this compound, the benzene ring at the functional group, is known as what? Benzoic acid. The name of this is known as what? Phenol. Alright, everything is phenol. Then everything here is known as what? Benzaldehyde. Benzaldehyde. Now, how do we now identify the auto meta para system? Now, watch this. If, for example, we want to identify where the auto and the meta para will be for this. Alright, now we are having COOH at this point, right? Now, where you are having the functional group, that is where you start your one from. The functional group, where you have the functional group, is where your one lies. Alright, so your one is here. Now, to get the para, it is very easy. Alright, please, para is the side that is directly opposite the functional group. The para position is the side that is directly opposite the functional group. So which side is directly opposite this functional group? This side, right? So this becomes our para. So now this is our one where we have the functional group. Now after your functional group, all right, the side. Now the first area you go to, the first corner, if from this side or from this side, they be what? Your auto, and here will be what? The para, sorry, your meta, and here will also be what? The meta. So it becomes auto meta para. So please take note, the para position must be directly opposite the functional group. Alright, so if we look at this, so this our functional group is what? 1. This side is 1, right? So here is 2, here is 3, here is 4. Here is 1, here is 2, here is 3, and here is 4. So that is why your para position is 1, 4. Your meta position is 1, 3. And your auto position is 1, 2. Please don't forget this. 1, 3, and then this guy, you have it as what? 1, 2. So please don't forget, the para is directly opposite the functional group. Now, what if you are given two functional groups? Then you now have to know what is called the functional group priority. Alright, it is a table where you have list of functional groups, and the one that have the highest priority or the one with the lowest, from the highest priority to the least priority. Okay, now carboxylic acid COOH have the highest priority ever known. Carboxylic acid COOH have the highest priority ever known. In fact, it is the highest functional group with the highest priority. Carboxylic acid COOH is the functional group with the highest priority. So no matter any type of functional group we attach to this compound, all right, this guy remains what? The priority. So this guy will carry what? The 1. All right, the carbon, the side where it is attached to, will be our 1. So let's take, for example, I give you this. And I decide to put, let's say, um let's put, okay, what should I put now? Okay, let's just put OH for example. Let's just put OH. All right, let's just put OH for example. Now, having this OH here, now remember I told you that this guy has the word highest priority, so definitely this will be our one. All right, so our one, our two, our three, and our four, our one, our two, and three, and four again. So remember, just look, this side is directly facing what? The functional group, right? So it becomes what? The para position. So it means that the OH is para to what? The functional group. So what do you now call this? You now call this para hydroxy benzoic acid. Becomes what? Para hydroxy, or you can just put it as P hydroxy benzoic acid. So all right, what if I decide to change this? Remember, this guy is called what? Phenol. This guy is called phenol. What if I decide to change this and I put something like, on this position, I put chlorine, Cl. So what will it now be? It will now be what? Now, this Cl is at what position? This is the functional group. This guy is higher than this halogen priority. Don't worry, I'm going to drop another video lesson where I will talk about the priorities, all right, of functional group. So please do well to subscribe to this channel so that you don't miss on anything. So now we have this. Now listen, watch this. Watch this. So this is where we have our one. So there will be our auto meta para, auto meta para. So this will be the para position. This will be the meta, this will be the meta, and here this will be the auto and the auto. So we now have auto chlorophenol. Auto chlorophenol. That will now be the name of this. Then lastly, for this guy, which we know to be benzaldehyde, and I decide to now put, let's say, I decide to put something here. Let me put bromine, for example. I decide to put bromine. So now this is auto, right? No, these are one. Sorry, these are one. These are two. These are three, and these are four. These are two. These are three. So this is auto meta para. Auto meta para. So it now becomes what? Meta bromo benzaldehyde. So please take note. Now, when you are giving two functional groups, if they are substituent like this and this, it's very easy. But what if you're not giving another functional group? So you have to have the idea of the priority table of functional groups. So with that, you'll be able to know which one will be where the functional group that will be carrying the side, all right, with the functional group that you have to bear one. So if you can identify the higher functional group priority, then you know that that side that is carrying that higher functional group priority is your one. So once you just identify that, then the next side is your auto from this side, and from this side it becomes what? Your auto. Then you have meta, and then you have para. So you can have two auto, you have two auto, all right, two meta, but only one para. Okay, so but the para is just opposite, so I can still call this position para. If I bring this functional group here, this position becomes para. So please take note, para, the para position is directly opposite the functional group. Thank you very much for watching this video lesson, and I'll see you in the next episode.